Hi guys, so what we're going to be doing today is we're going to be using trig ratios to find other ratios. So this is really just a continuation of the topic that we were doing last time, but it's really kind of just more complicated problems. And in order to solve the more complicated problems, we're going to need a little bit more effort. Actually, we're just going to combine two things that you already know. Okay, so here's something that we did kind of last time. If I said here's like the sign of something, like if I said, let's see, suppose sine of theta is 1/2. Find cosine of theta. All right, you would be able to do that with some effort. Okay, the problem is if they tell you that sine theta is 1/2, you would have to go to the unit circle. Drawing a unit circle, good enough. So you'd have to go to the unit circle, say, okay, well, sine theta is 1/2. That means that the y value is 1/2, which means it's over here or it's over here. So maybe they gave you another piece of information. So maybe they say find cosine theta if theta is in quadrant 1, right? Something like that. So then you know it's actually this one over here, right? So you've got this point. You know that the sine value is the y value, right? Like sine theta is y. So you've got this x coordinate that you don't know, and you have the y coordinate that is 1/2. And from there, you can find the 1/2 with some work, right? Then from here, I'm not going to finish this problem, by the way, but from here, what you would do is you would have to say, okay, well, use x squared plus y squared equals 1, the equation of the unit circle, to find the x value, right? Because x is missing. And then once you had it, then you'd be able to say, and now cosine theta equals x, which you know, because you just found it in the previous step. All right, and that's how you would do this problem if we were in the previous section, and we did some of these, okay? But it's a little bit harder when instead of having sine and cosine, what if it's secant and a tangent? What if they tell you the tangent and want the secant? That kind of thing is harder. And so this method that we've got here is not impossible to use in those cases, but it's also not the easiest way to do it. So what we're going to do is we're going to have a method that combines the unit circle stuff that we know with the right triangle trig stuff that we know, and together we're going to have an easier time solving problems like this one, okay? And that's why I'm not finishing this one, because we're going to not do it this way. We're going to have a better way, okay? So here's the idea. Actually, before I give you the idea, let me just say what you need to know. So let's see. We have a better way to do this. Better way to do this type of calculation using a combination of right triangle trig, which we haven't used in a while now, a couple lectures, right triangle trig, and unit circle trig. Write that right there. Okay. Right? So we have two kinds of trigonometry, and we want to combine it. Okay? And so the easiest way to do this first part here, right? So if you have a sine and you want the cosine, the easiest way is not to use the x squared plus y squared equals 1 and that kind of stuff. It's actually easier to use a right triangle. Okay, so we're going to recall right triangle trig. What do we need from it? Well, basically what you're going to need for right triangle trig is just the formula for all 6 trig functions, which is, oh man, once I do one thing wrong, then everything goes wrong. All right, theta. So if you have a right triangle like this one, we labeled the sides. Remember, there was an opposite side, there was an adjacent side, and there was a hypotenuse. And then we had 6 trig functions. We had sine theta is opposite over hypotenuse. We had cosine theta, which was adjacent over hypotenuse. We had tangent theta, which was opposite over adjacent. And then we had the 3 others. We had cosecant theta, which was 1 over the sine, so it's an upside down sine, hypotenuse over opposite. We had the secant theta, which is 1 over the cosine, so it's the hypotenuse over the adjacent. And then we had the cotangent theta, which is 1 over the tangent, so it's the adjacent over the opposite. And so we've already learned this, okay? What we're going to do now is when we have a problem where they tell us one of the trig functions and they want another one of the trig functions, is we're going to draw this triangle. And the triangle's easier to work out than the unit circle is. And so that will save us some effort. The only thing we're going to need from unit circle trig is the stuff about what sign different things are, or what sign the trig functions have in different quadrants. So here's the idea. Let me write that. Idea. So we're assuming that they give us one trig function and they want another one. So they give us one trig function. So they don't give us the angle, but they give us a trig function and want another trig function. Right? What you're going to do is you're going to draw the triangle that corresponds to the trig function that they gave you. The right triangle. I'm just going to say for the trig function that they give you. Given. All right, draw the right triangle for the trig function given, and then what you're going to do is you're just going to use that triangle to come up with the trig function, the new one, the one that they ask for. Use the triangle to find the trig function you want. But the only extra thing you need to do is we're still going to be thinking about unit circle trig. So if they told you that your angle was supposed to be in quadrant 3 or quadrant 4 or something like that, then you get the sign plus or minus from that information. So this is the only 2 steps, but for that last one, you determine the sign, the plus minus sign, that kind of sign, using what you know about unit circle trig. So the idea is that you're combining what you know about right triangle trigonometry and what you know about unit circle trigonometry in order to make this problem easier than it would be. Right? Now, that might be hard to understand, so we're going to, of course, do examples. So here's an example for you. Given tangent theta equals 5 over 12 and theta is in quadrant 2. Okay, there's a typo here. I already have to fix it. Theta is in quadrant 2. Find secant theta and sine theta. Okay, so the typo was I need a minus sign here. Okay, so tangent is negative 5 over 12, not positive 5 over 12. All right, so let's see if we can look at our steps and figure this out. So what we're going to do is we're going to draw the triangle, the right triangle, corresponding to the information that they gave us, which was tangent theta is negative 5 over 12. And notice that, I just put the negative in the numerator. That's fine. You could put it in the denominator as well, but just put it somewhere. All right, so draw the right triangle corresponding to negative 5 over 12. Well, how do you do that? So what you do is look at the definitions here for right triangle trig. They gave us the tangent, right? Yeah, they gave us the tangent. So the tangent is the opposite over the adjacent. So what that's telling you, if the tangent is the opposite over the adjacent, then negative 5 over 12 must be the opposite over the adjacent. And so we're going to assume that the adjacent side is 12. And we're going to assume that the opposite side is negative 5. Now, normally you wouldn't label the side of a triangle as negative 5. So, you don't need to. You can just label it as 5 if you want. It's literally not going to make a difference in the problem because we're going to get the sign from unit circle trig anyway. So if you want to write negatives, write them. If you don't, just throw them out and it'll be fine. Okay, so here's my triangle. Now what I'm going to do is the adjacent side should be 12, so that's down here. The opposite side should be 5. It could be negative 5, but I'm just going to put 5. Okay, that looks like that. Okay, 5. So there you go. Now when you draw that triangle, you're going to be missing one of the sides, right? Because the trig function that they gave you only is going to tell you 2. So you have to find the third side. So just find the missing side, which you've done. Find the missing side. So you're going to have to use a squared plus b squared equals c squared to do that. And remember when we did this before, the hypotenuse has to be c, but it doesn't matter which side is a and which side is b. Like opposite side could be a or b, adjacent side could be a or b. All right, so let's work this out. We're missing the hypotenuse, by the way, right? This is the hypotenuse here. So put in the 5 and the 12. They must be a and b. So put them in. 5 squared plus 12 squared equals c squared. So 5 squared plus 12 squared, so that's 25 plus 144 is c squared. So 169 is c squared. And that means c is going to be the square root of 169. And that should be 13. Okay, so c is 13. So you go back up to your triangle and let us label that as 13. Okay, good. That's it. That's our triangle. Now let's move on to the second step. So the second step is use the triangle to find out the trig function that you want. All right, so we'll just go to that, too. Now we're going to use triangle to find, well, what are we looking for? Secant theta and sine theta. So we have secant theta, need a little bit of space, and we need sine theta. Leave a little bit of space. All right, so secant theta. How do we get secant theta? So again, we're using a right triangle. So secant theta is hypotenuse over adjacent. So hypotenuse over adjacent. Okay, so what side is what? So we have a hypotenuse, that's 13. and the adjacent side is 12. So there you go. That's the secant, almost. Remember what we have to do though is we have to determine the plus or minus sign using what you know about unit circle trig. So what quadrant are we in? We're in quadrant 2. All right. So if we're in quadrant 2, quadrant 2 is here, right? And remember that the way this worked was all of the trig functions were positive there in quadrant 1. The sine was positive in quadrant 2. The tangent was positive in quadrant 3. And the cosine was positive in quadrant 4, right? And remember that it wasn't just the sine that was positive in quadrant 2. It was the sine and it was the cosecant, right? Because those are related. Right? These two are related, have the same sign, because they're just upside down versions of each other. These two are related, and these two are related. So, in quadrant 2, the sine value is positive, right? So I'm going to write this out. In 2, sine is positive, and cosecant, right? But cosine is negative, right? Because the cosine, like when we put the s there, we know that sine and cosecant, but not the cosine and not the tangent, right? Because x is negative on the left-hand half here. So sine is positive, cosine's negative. So if the cosine's negative, then the secant must also be negative, because the secant is cosine upside down. So actually, it's not 13 over 12, it's negative 13 over 12, because it's not a sine or cosecant. All right, and that's the first one we need. Now let's do the other one, sine theta. So sine for a right triangle is opposite over hypotenuse. So opposite over hypotenuse, which is, opposite is 5, hypotenuse is 13. So we have 5 over 13. And again, we're in quadrant 2. So in quadrant 2, is the sign positive or negative? Answer is it's positive. So it's positive 5 over 13. All right, and that's how that goes. So let's probably do another one, and we'll figure it out. Oh, actually, here's a slightly different thing. Let's do that first, and then we'll come back maybe and do another one. Sorry, just looking for a good problem here. Don't know if I'm going to find one. Okay, this is a good one. Okay, example. So, given cosine theta is 3 square root 13 over 13, and theta is in quadrant 4. Find sine theta. All right, let's try to do it. So again, the idea is we can draw the triangle that goes with this. So we have cosine theta is 3 square root 13 over 13. So we just draw the triangle. All right, well, we need to know what sides we have. So you look up the cosine. Cosine is adjacent over hypotenuse. So the adjacent side must be 3 over, or not 3 over, 3 square root 13. Like that. And the hypotenuse must be 13. Like that. Well, once you have the two sides that you know, you're going to need to work out the third side using the Pythagorean theorem. So we're going to use a squared plus b squared equals c squared. Remember, the 13 has to go in for c. The 3 root 13 can go in for either one. So let's just call it b. So we get this. Work this out. So we have a squared plus, you have to square this. When you square 3 square root 13, remember that you're squaring both of these, right? The square is on both. And here, what's 13 squared? 169. So we have a squared plus 9 times 13 equals 169. What is 913? Sounds impossible. Hold on. 13 times 9. 3 times 9 is 27. 1 times 9. Is it 117? Could that be right? Oh no, hold on. 90 plus 27. Yeah, that's right. Okay. So we have a squared plus 117 is 169. So a squared is 169 minus 117. Need a calculator. 52. So a is going to be the square root of 52. Now, does 52 have, like, what goes into 52? That's 26 times 2. So it's 13 times 2 times 2. It's 13 times 4. Is that right? 13 times 4 is 52? How could that be? 13 times 4. Whoa. All right. So that's a is square root 13 times 4. But you can do the square root of 4 and get 2. So that's 2 square root 13. All right. So we got that third side. Now we want to, oh, by the way, let me just show you this too. So you should be able to do this by hand, that finding the third side. But if you want, like, where are we? At some point, like maybe this point right here, I mean, you can just type that in to a computer, make it solve it. I'll show you that. So we got 3 root 13 and 13. So you can come to like Wolfram Alpha, and you could say a squared plus parentheses, what was it, 3 times square root, make that bigger, 13 parentheses squared equals, and it was 13 squared, so like that. And if I just hit enter, it'll probably just tell me what a is. Maybe. There we go. We get 2 answers, and one of them is 2 square root 13. So if you want to check your answers, you know, you can just type it in to Wolfram Alpha or something like that and get the answer. So, okay, so we got a triangle. Once you have the triangle, then we should calculate what we want, which is, what do we want? Sine theta. So sine theta is, well, we know it's going to be the opposite over the hypotenuse because we memorized that. So opposite is 2 square root 13. Hypotenuse is 13. And we need to just think about whether it should be positive or negative. So you have to look at the unit circle. Hey. So quadrant 4 is down here, right? They said quadrant 4, right? Yeah, quadrant 4 is down here. So in this quadrant, x is positive, but y is negative. And so should the sign be positive or negative? Well, we remember that the sign should be the y value, so it should be negative there. Or if you remember just the rules, right? A smart trig class, then that's telling you the cosine is positive in quadrant 4. So the cosine is positive, not the sine. So sine's negative. And that's your answer. Okay, so that's another one of the same type of problem that we just did. Now, what else can we do here? There was something else that I liked. Give me a different one. Oh yeah, okay, so there's this. So here's a problem that you can do. It's a different type of thing. Sometimes what they'll do is the following. So you've seen problems like this. So I want a different color. You have seen this. What have you seen? If they tell you, if they say, like, let's see, the terminal side of an angle crosses the unit circle at, and they'll give you a point, right? And the point could be whatever point. So like maybe the point is like 3/5 comma negative 4/5, right? And then they can ask you for some trig function. So they can say find, you know, tangent theta and secant theta, something like that, right? And you know that you have formulas for the tangent and the secant in terms of the y and the x values, right? So you just say, well, the secant is 1 over the x value. You can get that easy. And the tangent is going to be the y over the x value. Okay? But you're going to see something slightly different in this section. So in this section, you're going to see this. They ask, here's an example, given the terminal side of an angle theta goes through let's say 12,5, find cosecant theta. You know, just one of the trig functions, it doesn't matter what, right? So what is different, right? So look at this, what is different here? So think about it for a second, switch colors. What's the difference? So the difference is in the second example there, the point that they give you is not on the unit circle. The point given not on the unit circle. That's the difference. Okay? So that means you can't just use the formulas. You can't use something like this. Like cosecant theta equals, what was it? 1 over the sine. So it would have been 1 over y. Right? You can't use that formula because that assumed that xy was on the unit circle. That formula required xy to be on the unit circle. All right, how do we handle that case? Well, it turns out that what you can do is this. I'm going to draw a picture. You don't need to draw this picture every time. There's going to be a formula that you can use. But here's the idea. So I need a unit circle, so let me draw it. Unit circle is going to be little. Okay. Now I need to move that. Come on, let me move it. Why? No. Okay, fine. Good enough. All right, so there's my unit circle, so it's little. The reason I'm drawing it little is because its radius is 1, right? So if you have a point like 12, 5, 12, 5 might be, way up here or something. Actually, this is not even going to be far enough away, but you just imagine that that's 12, 5. Okay, like way over there. And so this is what your picture looks like. And in order to use the formulas you would have to know what this x and y are. And you don't. Okay? And so basically what you have to do is have a separate set of formulas that from this will give you this. Although it's better just to memorize the formulas for the sine and cosine and all that rather than the formula to actually give you that x and y. So this is really just a picture of why it doesn't work, right? Why you can't just use 1 over y, because the point is way over here and the unit circle is little way over here. Okay, so that's why you can't use those formulas. But there is a set of formulas that you can use, and we haven't given it to you before. So the easiest way to adjust it is as follows. So the simplest way, and it is simple, so I'll just say the simple way to do this is to use different formulas. So the adjustment factor to deal with the fact that the point is not on the unit circle is as follows. What you're going to do first is you're going to calculate a new thing called called r. Calculate r equals square root x squared plus y squared. And that's not this x squared plus y squared. I'm going to erase that. That's this x and y. Okay? So you have an x and y that's not on the unit circle. So you're going to calculate this r. And then, once you have that, you're going to use 6 different formulas for the trig functions. The formulas you're going to use now are, like, what was the sine function for on the unit circle? It was just y, right? Now what you have to do is divide by r. And the cosine of theta used to just be the x value. Well, now you're going to divide by r. Now, why is that the case? Like, why are we dividing by r? So the reason is as follows. So if the original point that they gave you, like this 12, 5 here, is x, y, then the point over here actually has coordinates x over r, y over r, the one on the unit circle, right? Because the thing is that, like, this point is too far away. Divide by r, and it'll give you the point on the unit circle. So that's the adjustment, divide by r. And then once you have those, the first sine and cosine, the other trig functions you just kind of work out. So let me just kind of move this out of the way so I have more room. So you have sine and cosine, tangent. Actually, tangent stays the same, y over x, because if you divide sine over cosine, which is another formula for tangent, then the r's just cancel. So tangent's y over x. Cosecant, that's 1 over sine, so that's r over y. And then secant theta, which is 1 over cosine, so that's r over x. And then cotangent, which is 1 over tangent, so it's x over y. All right? So these are just formulas that work when the point is not on the unit circle. So let me label this, because you don't need these formulas unless your point's not on the unit circle. So, come on. So you use this when xy is not on the unit circle. Now you can use it when xy is on the unit circle, but what happens is r is 1, and you just get the formulas that you were using before. Okay, So now let's actually do a problem. We're going to do the problem I think I wrote. So what was the problem that we wrote? Given the terminal side of theta goes through 12, 5, comma, find cosecant theta. All right, so here's what you have to do. Calculate r, which is x squared plus y squared square root. So it is 12 squared plus 5 squared. So that's the square root of 144 plus 25. So it's 169. Square root, you get 13. Okay, so you've got the r. Then we want cosecant, but we're not going to use the original cosecant formulas or the right triangle. We're not going to use the right triangle or the unit circle formulas. We're going to use these formulas, the ones we just came up with. So cosecant theta is r over y. And then we fill in the numbers. So what's r? 13. What's y? 5. Done. It's that easy. Okay, so now you've got 3 sets of formulas, really, if you think about it, right? You've got, so now you have 3 sets of formulas for trig functions. One, let's see. Let me do this actually. You have 3 sets of formulas for the 6 trig functions. Right? You got 1 set for right triangle trig. You've got 1 set for when you have a point on the unit circle. And now you have point not on unit circle. Right? And so you just have to use the right set. So if you've got a point on the unit circle, you use the middle one. If you've got a triangle, you use the first set. If you've got a point not on the unit circle, then you use the one that we just came up with. Right? There you go. All right, one more. Let's see. Theta is in standard position. And crosses the unit circle. At a point -8/17, -15/17. Find cotangent theta. All right, so how are we going to do this? We've got cotangent theta. What formula do we need? Well, we could use this, right? But this set of formulas is supposed to be when xy is not on the unit circle. So we could do this, but it'll be too much extra effort. So let's scroll up. We could use this set of formulas. This set of formulas is for when you have a right triangle. But we don't have a right triangle, we have a point. Uh-oh, we don't have the formulas here. So we need the first set here, right? No, second set, point on the unit circle. So if we have a point on the unit circle, then we're using this set, right? Sine theta is y, cosine theta is x, tangent theta is y over x, cosecant theta is 1 over y, secant theta is 1 over x, cotangent theta is x over y. And this is going to be the point on unit circle formulas. So what are we using? Cotangent, so it's x over y. Fill in the numbers. What's x? Negative 8 over 17. What's y? Negative 15 over 17. All right, so when you have a fraction over a fraction, remember how to do that. Negative 8 over 17 times, when you're dividing by a fraction, that's multiplying by the reciprocal. So this is what you have. Those 17s will cancel, and then it's negative 8 over negative 15, but those will cancel, and we're just going to have 8 over 15. And that will be our answer. Okay? So 3 sets of formulas for the trig functions, and you use the one that matches best with what you're trying to do. All right, so one thing I will say, one last thing, and then we'll stop. So something that we've been doing is when we've been asked to find, let's say to find cosine when given sine, we've used this formula. X squared plus y squared equals 1, right? That's on the unit circle. However, what you can do is you can say, well, if you're on the unit circle, isn't the cosine the x value and the sine the y value? Right? Sine theta is y and cosine theta is x. That's only on the unit circle. But, let's just say we are. That's the case. And if you actually take these and you substitute them in that formula, so substitute that in, and you get cosine theta squared, that's x squared, plus y squared, which is sine theta squared, equals 1. Or written this way, cosine squared theta plus sine squared theta equals 1. Now, this is always true. It doesn't matter if you're on the unit circle or anything. This is always true. This is always true. Okay. It comes from this right here, right? It kind of looks like this as well, right? A squared plus b squared equals c squared. And you can relate this formula to this, and the a squared plus b squared equals c squared is called the Pythagorean theorem. So cosine squared plus sine squared equals 1 is called the Pythagorean identity. So it's always true. So we call it an identity. We're going to have a lot of them later on in this class. So we call it an identity. Means something that's always true. This one is called the Pythagorean identity. Right? And if you're looking at the computer, Newton Alta's work for some of these problems, you'll see them use this even though I didn't, to solve problems. So like if you have a problem like this, like if they say let cosine theta equal negative square root 10 over 10. Theta's in quadrant 2. find sine theta. I would have started, when I solved this problem, with x squared plus y squared equals 1, right? I would have gone x squared plus y squared equals 1, and then I would have taken this cosine, and I would have ended up putting it in there for x, because the cosine is the x value, right? And that works. But you could use this Pythagorean identity instead. You can use, I'll write it this way, sine squared theta plus cosine squared theta equals 1. And then you can fill that in, that cosine. Plug in cosine theta equals negative square root 10 over 10. So you end up with sine squared theta plus, now you have to be careful here. Cosine squared, look where the square is. You still have to make sure you square things. Don't let where the 2 is written confuse you. So you put in the negative root 10 over 10 like that for cosine, and it's squared. Equals 1. And then what you do is you just solve for sine theta. And using this identity lets you find sine theta directly without having to talk about x and y's. Okay, so that's the only advantage, and that's pretty much why they use it in this section. So it's just the same as solving it in this form, in the x squared plus y squared equals 1 form. We're just calling x cosine, and we're calling sine y, or calling y sine. All right, so sine theta, sine squared theta is there, plus, okay, we got to square that. If you square negative square root 10, you're going to get 10. If you square the denominator, which is 10, you get 100. So you have this. Subtract this. So let me actually rewrite it. So 10 over 100 is 1/10. Then subtract 1/10 from both sides. So you get sine squared theta is, well, on the left side it cancels. On the right you get 1 minus 1/10. So sine squared theta is 9 over 10. So now you have to square root, right? This is sine squared, right? Remember, sine squared theta just means sine theta squared. It's just written a little bit weird. So sine theta is going to be, how are you going to get it? You're going to square root this side. So square root top and bottom separately, you get plus or minus. Square root 9 is 3. Square root 10 is just square root 10. So you get that. Should it be positive or negative? Let's figure it out. What quadrant are we in? 2. So in quadrant 2, all of them are positive in quadrant 1. Quadrant 2, the sign is positive. Sign is positive. So sign is positive. So we have sine theta is 3 over square root 10. Now, we don't like to leave it that way. We're told we should rationalize the denominator. So we did that earlier today. So how do we rationalize the denominator? Do you remember? So we need to rationalize. You're going to multiply by square root 10 over square root 10 and see what you get. On top, you get 3 square root 10. On the bottom, you get square root 10 square root 10, which is just 10. Okay, and I didn't write it here, so I'm going to write it. We said it out loud. In quadrant 2, sine theta is positive, and that's why we have the positive square root 3 over 10. But this is how we write it for our final answer, with a rational denominator, which means no square roots in the denominator. Okay, so I think that's it for this. And yeah, I think that's it for this. See you next time.